Good morning or afternoon, depends where you are, I suppose. Welcome. Today I'm going to teach you what is an operating system. So, if you look on the screen at the moment, you can see various different logos which represent a range of different operating systems. You can see that they're Microsoft Windows' operating system, Apple's Mac OS, Google's Android, and also I believe that the bottom right is the symbol for Ubuntu. I might be wrong, which is a version of Linux. Up there you can see the Linux Penguin as well. So you'll be aware, I hope, that the operating system provides you with effectively the screen that you see when you turn on your computer, and it provides kind of like a platform for all other pieces of software to run. Many of the things that the operating system does, however, are really hidden from your view, as in you can't see them. You'll probably be aware, as a minimum, that you use an operating system to install, run and uninstall programs. And also, you're going to use the operating system to configure system settings. So you might change the color of your desktop, or you might change the way that the mouse behaves. Equally, you might have seen some network administrators use operating systems to set up user accounts and passwords and track your usage of the network. Again, that's another use of an operating system. And finally, you'll probably be quite familiar with the fact that you have to configure the settings of the operating system in order to connect to the internet. And so there's a range of different functions which the operating system undertakes. I'd imagine, however, that you'd be quite unfamiliar with what goes on in the background. So the types of jobs that the operating system does on your behalf in order to fulfill those roles I've just spoken about. I think the first thing that you need to consider when kind of getting your head around the role of an operating system is that they're not a single program. And often you hear parts of the operating system being referred to as components, but I think it's wrong to think of it like that. There are actually separate executable files that all work together to provide you with the operating system. I think when I was putting this video together, one of the hardest things was actually trying to get to a model of an operating system, and I looked up different images of Windows, Linux, and Mac OS, and I found really varying different kind of graphics and schemas of how an operating system looks, and it can be quite, for someone who's a novice computer scientist, it can actually be quite off-putting. And what I did find out, however, was that there's kind of like a minimal set of components that they all have, and that's really what I want to get out of this video and let you know what these components are and the sort of the terminology of operating systems. So I came up with this diagram, which I think is, I would say, pretty universal to all operating systems. I really welcome comments if people think that there's something that could be moved or placed into a better position, or think a large thing that I've missed out. So effectively, in an operating system, you have a thing called a kernel. That's the bit that I've just highlighted. This is the nuts and bolts of the operating system. It performs roles like the control of all the different processes on the computer. By process, I mean an instance of a program. So when you double click on a program, that program running, and also the fact that the operating system can be running more than one program at once. So it allows the operating system to multitask and just flip from process to process to process. That's called scheduling. It also manages all your files, so you'll be aware that you've got a hard drive and maybe a USB drive, but that's all kind of abstracted away from you. The actual workings of placing stuff at certain addresses on the hard drive is not a problem for you. There's this hierarchical directory that you look at. And so the kernel is basically doing the back-end work, and it's programmed in a low-level language, and as a user you will never ever speak to it. The way in which the programs communicate with the back-end, with the kernel, is through the application programming interface. And so this is effectively a set of libraries that are designed to interact with the kernel, and the API is said to make system calls to the kernel. So for example, I want to open a program or I want to save a file. That's just done through the API. So the programs can be written in a high-level language that never have to talk directly to the kernel. So as I mentioned, an operating system comes packaged with a range of other programs which help the user configure settings, launch programs, manage the hardware. And actually the best way for you to look at these programs, if you're on a Windows PC now, you can just press Control-Alt-Delete. What you'll see is a range of background processes, each of which is part of the operating system. And so these programs are listed up here, and there's a range of different ones, and each one of them is viewed as can be viewed, I think, as a separate program. They might be referred to as components in different operating systems, but I think the best way for you to get your head around it is that they're a program in the same way that Microsoft Word is. So these programs include things like the user interface. So the graphical user interface. So effectively, when you look at the screen, you are seeing like the mouse move around, you're seeing windows, you're seeing icons, you're seeing menus, you're seeing pointers. All of these things make up the graphical user interface. Briefly reading around it, I believe that the Windows PC, the actual graphical user interface is quite low level, so it's built into the kernel, but on a Linux device, which is another operating system, they actually allow, it's a separate program to the extent that you can install and uninstall graphical user interfaces, and hence get completely different experiences of how to use the actual operating system. And as well as the graphical user interface, you've got a thing called the shell or the command line. I will get open the command line on my computer. So got it. Okay. So this box here is the command line. So basically, this is a text-based interface that allows you to make system calls. And so you can run command line programs, you can open up other programs through this. In fact, in the early 90s, most operating systems just looked like their box. They didn't have the Windows icons, menus, and pointers, but they're still there. They're actually a really effective way, if you learn the command shell instructions, a really effective way of managing your computer. So, as well as the graphical user interface and the command line, there's a range of functions for managing system security. So this is principally user accounts, but on a mobile phone operating system, for example, you might have a thumbprint scanner in order to log in. That's provided by the operating system. On a desktop operating system, you might have a username and password that you type in. And so the operating system is basically managing these accounts, and it's also managing the permissions that are set to each account. So each account will be allowed to look at certain programs, be able to access certain areas of the hard drive. That's all managed by the operating system. There are also other programs that often come packaged with an operating system for managing security. So things like a firewall or antivirus software often come packaged into the operating system. Also, in addition to that, operating systems also provide you with a tool for managing all your files. So on Windows, this is called the File Explorer. This is a separate program. It's called Explorer.exe. And so this is, again, an interface between you and the actual hardware. So this program of File Explorer.exe, it makes system calls via the API, and then it moves files from one place on the hard drive to another. The actual hierarchy of files that you see on here doesn't actually exist, because the hard drive is just a linear sequence of ones and noughts, and so this is again an abstraction that makes things easier for you to use, that's provided as part of the operating system. So you might have noticed that in my diagram that some of the programs are part of the operating system, as in this shaded area here, and some programs don't appear to be on there. So these ones in the top right corner, and there's a reason for that. So your applications, those are the bits of software that you install onto the operating system that do something useful. So for example, like Microsoft Word is an application because it's useful when writing letters, or a computer game is an application which is useful for sort of mindless entertainment. Utility programs are also kind of almost optional extras to the operating system. So for example, like an antivirus software, you would buy an antivirus program from McAfee and then install it onto your operating system. I've also just highlighted then libraries. So libraries were quite hard to place on this diagram because the application programming interface is itself a library, but there are additional libraries that have been written that in turn interface with the application programming interface. So for example, there's a library called DirectX. It's used by Microsoft for drawing 3D things on the screen. It's used in a lot of games, and it's an additional library that doesn't come bundled in with the operating system necessarily. And as such, it needs to be installed on your computer. It doesn't do much use by itself, but certain other programs might rely on these libraries. The wider format of libraries is there are these things called DLL files or dynamically linked libraries, I believe it stands for. This is basically programming code that makes it quicker for a programmer to create a program. And so these DLL files, the code in them is shared between multiple programs. You might find that if you install a program, then all of a sudden, and you then uninstall it and delete a DLL file that was linked to it, another program therefore might not work and you need to reinstall that program. So basically the DLL files are chunks of code that are used by a range of different programs, and they're stored in a thing called a library. It was kind of hard to place on this diagram because I kind of felt that the libraries should be down there with the application programming interface and then other things talking to it. Finally, I've kind of weirdly put browsers, media player and firewall up there as separate programs, whereas you'd be aware that a browser and a media player, both applications, they do something useful. A web browser allows you to do research on the World Wide Web. A media player plays media like CDs and MP3 files and things like that. And then a firewall is a utility program which stops people remotely accessing your computer on certain applications. So you block ports and say, right, no traffic is coming through on that port, and a port is associated with an application. So you can say, right, no one's going to speak to my web server, for example. So it blocks down ports, and that stops hackers. It stops like denial of service attacks where people are trying to just make so many requests off your computer that you can't handle it on the network. And also it blocks certain forms of malware which spread through open ports like worms. And so those three are up there, and you might be wondering, well, why do you separate those out from applications and from utility programs? Well, the reason for that is that they've all actually been quite contentious in the past when people have been distributing operating systems. So sometimes, for example, Windows has its own firewall built in called Windows Defender, and that would be viewed as part of the operating system. However, you can also buy other firewalls to work on your system. Equally, there was a whole court case in the 90s about the fact that Windows was bundling Internet Explorer with all of its operating systems, and as a result they felt that gave Windows an unfair advantage when it came into the browser market. I think the same was done if you look at, like, Windows PCs often have Windows Media Player on them, and Apple have QuickTime, and so sometimes there are applications that are not really necessary for the running of the operating system that just come bundled with it, and that's often for kind of like reasons based upon profit and the company trying to spread into different markets. And so I've put those up there just to say that sometimes stuff that's in the operating system really doesn't need to be bundled with it, and often it can be quite contentious as to whether something is in the operating system or out of the operating system, where in reality it's just an application or a utility package. Okay, right, so I'm just going to review what we've been covering. So we've got this idea of an operating system, and I really wanted to break you away from the concept that an operating system was a single program. Often on like GCSE computer science courses, they say, oh look, you've got the application software that does useful stuff, and you've got the system software and that just maintains the computer, and there are 4 types of software within that. There are operating systems, translators, drivers, and utility packages, and that makes you think that the operating system is just one program. It's not. It's a collection of programs that all work together to control hardware in order to run other pieces of software. Microsoft Windows is an operating system, and so is the Android which is produced by Google. Then operating systems have this chunk in the middle that's low-level code, and it's called the kernel, and it does all the nuts and bolts stuff. So it's a low-level program is designed just to manage the hardware, and it does things like process scheduling, memory management, and input-output control. And then the rest of the operating system is a set of programs that interface with the kernel through a thing called the application programming interface. That application programming interface is a set of libraries that are making system calls to the kernel, which will carry out a task like print this onto the screen or save this into a certain location. So I hope I've thrown a little bit of light onto the murky topic of operating systems, and I look forward to more videos in the future.